Hello, hello everyone. Welcome. Warm greetings from High Target. My name is Karen and I will be your host today. Thank you for your interest and registration for this webinar and hope we could bring the best we have got to provide a well-organized online knowledge sharing experience for you. As you may have known from our registration email, today's topic is about coordinate system settings and localization in high survey software, tailored for surveyors who may have been bothered by the complexity of conversion in GPS WGS84 coordinate system. Here we feel honored to invite Mr. Lance Lan, Senior Technical Engineer from High Target International Technical Group, to provide his explanation and solution to this problem, which consists of 3 parts. Between each part, there will be a Q&A section. You can also raise your hand by clicking the hand icon on your toolbar if you have any questions. Due to time limits, every Q&A section is open for only 3 questions. But don't worry, if your questions are not chosen and answered, you can also write down your questions in the message window and send it to us. We can gather all of them and reply you through email after the webinar. Okay, now let's welcome Lance to take the charge and show what he has prepared to share with us. Welcome, Lance.
Okay, thank you, Karen. Good afternoon, everybody. I'm Lance, a technical support from High Target. It's my pleasure here to attend this webinar. As we know, a datum is a mathematical model of Earth we use to calculate the coordinates and elevations on any map, chart, or survey system. Geodetics defines the size and shape of the Earth and the orientation of the coordinate systems used to map the Earth. Then how can we configure coordinate system in high survey? This is the topic that we are going to deal with in this webinar today. Before that, I would like to take a few minutes to introduce some key features of high survey to you. So this app has smart features powered by Android platform. So you may ask, why do we select Android platform? With the development of SaaS and token knowledge, the requirement of the speeds of the controller software become higher, and people want to have some controller which can be easily used at their phone. So we decide to develop an app which can run on Android platform, and we also believe that Android will be more and more popular in the future. So second, it is compatible with all high-target GNSS RTK products such as V30, V60, V100, V19 Plus, and so on. You don't need to worry about your old generation receivers. So as this picture shows you, in this interface, you will get 4 main parts from project, device, survey, and COGO. So, as you can see, it has a very clean workflow. Just set the project, connect the device, then go to correct point. So in the last picture is the interface of stakeout. As you can see, with this big green arrow, you will find what you want. It will make your stakeout work more efficiently, and it's very easy to use. Okay, right, let's get started. So I have divided my presentation into 3 main parts. First part, coordinate system and projection configuration in high survey. So I will show you the workflow in Highway. And second part is parameter calculation for plan and ellipsoid transformation. So it is like localization in other software such as Survey CE. And with this function, we can calculate parameters with 2 null points or 3 null points. The last part, we will talk about the usage of track points and the regulate point function. And track point is for people who works in small projects in small area who don't want to calculate with big value coordinates. They just want to see it clear. For example, they want to see the distance from 0 to 100. They want to see them in real time. Okay, let's go next. Coordinate systems and projection configuration. So after we run Highway in iHand20, our controller, or your Android phone, so firstly, we should create a project or open an existing project which we want to use in project info. Input a new name and click OK. So in this way, you can create a new project. Place an existing project for a while and you can open it. Next, so I will show you how to select a predefined coordinate system in library. So we can enter into project setting to set coordinate systems and click the Earth-like icon, predefined, and then you can choose the coordinate system according to your country and needs. Click Apply to finishing setting, and you can also define coordinate systems as you need. Anyway, don't forget to click Save, and the parameters setting will be done. So third, some surveyors may also need to use a geodetic file in their coordinate systems. So don't worry, Highway supports that. Just press a projection icon and into projection setting to set some details of coordinate system. You can choose to set height fitting and plane geodetic, which includes C grid and L grid as pictures below. So in Highway, we also have some special features. For example, you can show your settings to another user with 2 barcodes. And in this picture, you can see QR codes as picture below, and through this function, you can show your coordinate systems to others who will have the same setting as yours. So for example, in a project, you have 7 or 8 rovers, and you don't need to input the parameters one by one. Just set it well with one controller, and then use others, scan the QR codes of this controller, and you will get the parameters. It will improve your work efficiency, and you don't need to worry about maybe one of the controller you have inputed the wrong parameters. Okay, for sometimes maybe you will say that in the datum library, you cannot the predefined datum. So don't worry, we can create it by ourselves. First, we get in the project settings interface again and press the icon, Earth-like icon, and then we press the user default. And then you will get the projection setting interface and input a name here. Check the projection and enter ellipsoid parameters. And also you can choose the transformation model and input the boost hour parameters you have, and then press save. After that, the parameters will be changed. Okay, these steps include common coordinate system and projection configuration. Then you may ask, what if I have boost hour parameters or any other parameters? I only have few null points, or maybe only 2 or 3 null points for my project. So don't worry, I will show you the 2D Helmholtz parameter setting first, and how to calculate the parameters with null points, control point. Oh, so before that part, maybe anyone have some questions?
Okay, yes, I have seen that. Mr. Mid Showy actor has a question. Okay, you are free to ask. So please.
Hello?
Hello.
Hello?
Yes. Hello.
Hello? I can hear you.
Okay. How can I save this projection system for further use? Because when I'm trying to save this projection system, it's maybe okay, but when I'm trying to load preloaded project, so previously saved projection system, that it shows sometimes that it's missing or something new, as like it's forget that which parameter I saved previously.
Sorry. Could I pardon? So it is not clear for me. Could you repeat?
Okay. If I'm trying to save this projection system, right?
Yes.
Then this projection system sometimes show that it's saved, but when I'm trying to load it
Load it.
next time, then it shows that this parameter is gone. I can't find this parameter with this projection system. Then is there any system to make it as a permanent, as like previously you showed that boost trouble? Can I save as like boost trouble into my system?
Yes, I may give you a big yes that you can find it after you load you save the parameters.
Okay.
And you will find the datum parameters file in the project, right?
Yes.
Yes.
And
then you log it, long press it, and you can log it. I will show
okay.
you in the
later portion.
So in this interface, right?
Yes, 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 yes.
You can put your datum file in GeoPads photo,
Okay,
and here you long press it and press load, and then press apply. You
okay,
will get the parameters. Okay.
okay. But sometimes that it shows that my preloaded system is missing with some error that this parameter is maybe changed to other transformation system. Why it's occurred?
Um, so I may know your questions, but for now, I think it's not easy for me to explain you
Okay,
this issue. Okay. So please send me the email. Okay. I will show you
okay,
the details in the email. Okay.
okay, okay,
Okay.
Okay, thank you, Mr. Arthur.
okay. Thank.
Okay, I see Arden has another question. Okay, Arden, you are free to ask, please.
Hello, can you hear me?
Hello, Arden. Yes, you are free to ask.
Yeah, hello, Lance. I have a question. It is about the parameters for the Brusel-Wolf conversion. As we know that I may have some parameters from getting from the government or from some agency, but I don't know how could I input into the iSurvey software. For example, for the translation part, there's three parameters for the translation, and the value are positive. So should I input it for directly, or should I put it a minus, or I mean negative, into the software?
So if you input it in plus or minus in Surf
Yeah.
CE, and it's totally different. Okay. For example, you input minus 100, maybe you should input negative 100 in Hathaway.
Okay.
Okay.
Okay. So it's totally different from Surf CE.
To Hathaway. Mm-hmm.
Okay, understand. Thank you.
Okay, thank you, Arden. If there's no other, no everybody else who have a question, then we may proceed with the presentation.
So let's go start with the next part. Okay. In the previous presentation, and these steps includes common coordinate system and projection configuration. Then you may ask, what if I don't have Brusel-Wolf parameters? You only have few node points, maybe only 2 or 3. You have to use this control points, node points to calculate parameters. So I will show you in the next parts. So parameters calculation for plane and ellipsoid transformation. So first, let's start with principle of 2D Helmholtz. So and in this picture, you will see that in this formula, we know we should have 2 node points at least to calculate the parameters. But now, so let's forget the formula. And our coordinate system will have 3 steps to move. First is rotation. Second, scaling. Third, translation. And it should move in two directions. And in Highway, you need to use two node points, two control points, to calculate the parameters. And this function is used for some small projects, small area. For example, 2 kilometer multiplied by 2 kilometer, this area, and you will get good accuracy. And after that, after you input the two node points and press compute, you will get the results, get the parameters. Okay, let me show you an example. We have do a demonstration in China, Guangzhou, our headquarters. And here, in these pictures, we have 4 control points. Okay. And I will show you the workflow. First, we should create projects in Highway software. Then we set the coordinate system parameters, as I mentioned before. Third, connect the device and the set base and rover. Then after you get the fixed solution, we start the steps of 2D Helmholtz parameters calculation. Now here is the details steps of how to set the base and the rover. So we should care about some small parts to make our coordinates have to achieve high accuracy. So you should care the attendant height and database base data link messaging type, or you may not get the fixed solution. So is the rover. So after we get a fixed solution, let's start it from point A3. First, press the parameters icon into the setting interface, and press 2D Helmholtz, and press 8, and move your rover on A3. After you move your rover on at point A3, and you should collect that point as the video show you. So let's take a photo of these points. A3. And this picture will saved in your project with the name, and then input the polar height. And we press average to make sure it has a good accuracy, because we will use this point to calculate the parameters. And we select the local coordinate value from the list from the library. So if you input the wrong name, okay, now because in this video the name is A4, we just wrong place that point, and it will show you A icon, and then just change it to A3. So after that, we move the rover to A2, and we should do the same steps. So we also take a photo of these points, A2. And then save it in the projects, still average, to make these points have better accuracy. And also select the local points A2 from the list from the library and press save. After that, we press compute. Then we get the results and we press apply. We are updating the coordinate system. Then let's go to stake out A1. We get the stake out interface and select A1.A1 from the list. Okay, it will show you how far from you to that point. Just follow the big green arrow. You will get that point position. Okay, when you close to that point, and the big green arrow will become to 3 small arrow, and you will have more details information from 3 direction. Then we just stake out A1 to verify the parameters is good or not. Because the 2D Helmholtz parameters calculation is used for small area. If you have a big area, for example, you have a project, the area is 10 kilometers multiplied by 10 kilometers, and the two node points to calculate the parameters is not enough for your project. So you have to use more control points to calculate Bursa-Wolf parameters. So in these pictures, and you can see that it should move in 3 directions. So because we need more node points, more control points to calculate the parameters. So if you only have 3 control points, you may not verify the accuracy. The parameters is calculate well or not. So I suggest you have you used 4 or 5 node points to calculate the parameters. So it has the same steps with 2D Helmholtz parameters calculation. We just in the type we just select Bosa-Wolff, and then we use one more point. Then we press compute. In the right down console, we can get the results, and we press apply. So here's are the steps of 2D Helmholtz parameters calculation and Bosa-Wolff parameters calculation in Hathaway. So after that, I will introduce you how to use regulate points and track points in Hathaway. With this function, we don't need with regulate point function, we don't need always install the base on a control point. We can set the base in some good environments. So you may set the base on the top of the roof, on high, or maybe the mountain, and you will have a wide range with your lower. So in this picture, you can see that we set the base station beside the road. Now here I show you is the unknown, and then we move our rover to A3 to do regulate point function. And here I will show you a video of the steps. We click project setting and turn on the regulate point function. And we click into regulate points inform and click average. After that, we click OK and input node point coordinates. And press apply. And then we go details way to check the accuracy and coordinates. Then you can go to do your survey work. So compare with regulate point function. The track point function is moved after projection. So it's used for some surveyors don't want to see super number. They, for example, they would like to make A3 become 0, 0, 0. And after translation, they will easily know how far from one point to another point. It's good for them to reduce unnecessary slips. So we have the same step. We click checkpoint info and input source and correct points. Then input the null points and then press calculate and apply to get the result. Then you can check the coordinates in the detailed survey interface. So here I will also show you a video of the details steps. Okay, still have compared with regret points, it has 4 ways to correct points. One is average. So select no point from the library, from the list. And press compute. You will get the results. And click apply. Second way. Still average, but we will save that point in the library. Third, select point from the list, the source point from the list. You don't need to do it in real time. And then click OK. The last way, click flag icon. You could choose it on the map. And press OK. And then compute. Still get a result. So about this part, so anyone have any questions?
Okay. If everything is clear, I would like to call the presentation part to an end. It has been our honor to organize this webinar and share our up-to-date technical knowledge with you. And we thank you sincerely for your attention, care, and support in helping us with providing better service quality. If you don't mind, we appreciate if you could take 1 minute to complete 3 quick polls for us so that we could provide better audience experience in content, design, and organization aspects. Here comes the first poll. How organized was the webinar? Okay. Okay, we'll go to the next poll. Overall, how would you rate the webinar regarding the contents? Okay, thank you. Here comes to the okay, here comes to the last one. Thank you. The third question is, how would you rate the presenter's performance today? Okay, the polls are completed now. Thank you all very much for your support. Should you have any further questions, suggestions, or requests on webinar resources, please feel free to let us know by sending email to lens_lan@hightarget.com.cn. We are more than happy to help. Also, a video recording of today's presentation will be sent to your email. We look forward to having you as our attendees in next webinar. More up-to-date experience and knowledge sharing coming soon. See you next time. Have a great day.